Katie, we'll get started at about 3:07. I'm just letting people come in.
Okay, I'm just gonna try and connect to my laptop.
Oh, okay. Okay, so it's officially 3:07. If more people join, then they can just join as they please. But I'm going to officially get started. So thanks for coming to the webinar today. And that we'll be going over practice problems from the 2016 computer science free response portion of the exam. So first, I want to link you the PDF that has like the questions for the free response portion.
Okay.
So access that.
I'm still trying to get through with my computer first.
Oh, okay. Hello.
Okay, I'm connected now.
Okay. Um, so are you connected to like the webinar or like
Yeah. You can
the
send it
PDF
into
that I
the
sent you?
chat.
Oh, okay. Send it again. All right. Do you see the PDF? Okay. Naraz, are you able to access it?
Yeah.
Okay. All right. So, all right. So, this is the free response portion of the 2016 AP Computer Science A exam, or graciously gave out. So here we have pretty much this is exactly how the free response is going to look. I don't know if they've changed anything with like the timing or anything, but for this exam, it was 1 hour and 30 minutes. There were 4 questions, and it was 50% of the total score. So I thought that it'd be useful today to just go over these questions, have you try them, and then we'd go over them after a certain time, and then kind of just like explain our answers and explain like how we would get to the right solution. So I don't know if we're going to get through each question, but we're going to try. Since there are 4 questions and the webinar is about an hour, I was thinking that I would give you guys about 10 minutes per question, and then I'd save like 5 minutes in between to kind of explain like the right answer and like how you'd go through it. Does that sound good?
Yeah.
Okay. So we're going to start with question 1. I'll give you guys just like a couple minutes to read it, and once you've read it, then I'll give you guys 10 minutes to work on it. So have either of you finished reading the prompt? Hello? Okay. All right. So now I'm going to set a timer, and you'll have exactly 10 minutes to answer the question. Um, don't don't mind if you get stuck, because I'll be going over it after. But just try to do as much as you can. So 10 minutes starts now. Katie, are you able to hear me?
Okay, I can hear you now.
Okay. I mean, I've been talking this entire time,
Oh wow. Okay.
so
Yeah,
it's
I was working on it for 20 minutes and I thought it was weird that you haven't said anything.
oh no, I called time like a long time ago,
Oh my.
and I
Oh
actually
wow. Okay.
yeah,
Must be my
but
computer then.
mhm.
Um,
Okay, but you still have the PDF up, right?
yeah.
Okay, so do you want me to go over the answer again, or
Oh, no,
do
it's
you think
fine.
you
We can
got
just
it?
move on.
Okay, all right. So for number two, I'll give you 10 minutes again. I'll call when time is up.
Okay.
So your 10 minutes starts right now. Okay, time's up. Stop working. Oh, we're gonna go over the answers now. So let me share my screen. Can you see my screen?
Yeah.
All right. So for number 2, this is the question about the server, which has the log messages. And for part A, we have to write the constructor for the log message class. So it has to initialize the machine ID description, and the machine ID is going to be basically just the word or the phrase as before the semicolon, and the description will be everything that's after that. So to do this, basically what I did is I just used the index of method of the string class to find the index of the colon, and I called that colon index. And then I initialized machine ID to be the substring from the colon index. And if you know how substring works, it's going to go to colon index -1, so it won't actually include the colon. And then the description would just be the next character over, so colon index +1. And then I'd have that to the length of the message, so it'd go to the last character in the message string. And yeah, that's basically how you write the constructor. Is there any questions about that? Oh, all right. So if we go to part B, in this one we have to write the method called contains word, which returns true if the description in the log message properly contains a given word, and returns false otherwise. And the question basically outlines what it means to properly contain a keyword. So you have to be a substring. You can have to be you have to either be at the beginning or followed by a space, or at the end or followed by a space. And it gives you examples of like what properly contains means. So there is a really easy, or I wouldn't say easy, but relatively like short solution on the solutions guide on how to solve this. Um, Certainly you could have just went through and like checked all the cases before you returned true. But one thing that I thought was very good that they did is what they basically did is they took the description and they added spaces to both the beginning and the end, and then they used index of to find the index of the keyword. And so if you have the keyword and the keyword is at the beginning of the substring, then what we would do is it would you'd have a space and then the keyword, so it would be at the beginning. But if you also had it like in anywhere in the middle, then like it would count those spaces. Um, so this basically takes care of like if you have it at the beginning or the end. So you'd always have spaces at the beginning and at the end of the keyword. So if that wasn't the case, then it would return false. So does that make sense? Or are there any questions about that? Okay. So let's. All right. So for part C, wasn't able to finish this part, but basically, class represents, or this is a new class. The system log class represents a list of log messages, and provides a method that removes and returns a list of all the log messages that properly contain a given word. So you basically you have a list of log messages called message list, and you have a method called remove messages. And let's see. For the remove messages method, basically, I'm gonna maximize this so that you can see. What you have is you make a new list called removed, and this list will contain all of the removed log messages. Initialize a counter variable I and set it equal to 0. And then while I is less than the size of message list, you get the message at the current index I, and if message contains the word and the keyword, and you pass in keyword, then you basically add removed to the add the message to the removed list, and then you remove the message from the message list, like the overall message list I. And if it's not, then otherwise you just increment I, and then you just keep going until this loop ends, till it either reaches the end of the list or you remove like all the items, and then like the list size would be 0. And then finally, you basically return the removed list, and removed will have all the removed entries because you added them in this line. So yeah, that's basically how you do the remove messages method. Is there any questions about that? Are there any questions about that? Okay, so fortunately we're at 4. I'll give us like, since we kind of started late, I'll give us like probably like 15 more minutes so that we can do number 3, because I at least want to get one more in before we go. So this one is on 2D arrays, and I think that this would be a really good problem to go over, because 2D arrays are something that are historically perceived as challenging on the free response. So again, I'll give you guys 10 minutes, and once those 10 minutes are over, we'll spend about 5 minutes going over it. So I'll set the 10 minutes right now. And all right, so you have 10 minutes to answer number 3. And again, I will interject at 10 minutes and go over it. Okay, time's up. Stop working. We're going to go over it now. So let me share my screen. All right, so for number 3, this is the crossword puzzle problem. We have a crossword puzzle grid that's represented as a 2D-dimensional, two-dimensional rectangular array of black and white squares. So for part A, we have to write the crossword method called toBeLabeled, which returns true if the square row and column index should be labeled with a positive number, and we determine that according to the crossword labeling rule, which is specified here, and false otherwise. So we have the row index, the column index, and also the 2D array of whether there's a black square or not as parameters. So I did a little bit differently, but the answer from the answer key is that they use just a single statement where they return not black squares at RC, and basically this says the black squares, or if the square at the row and column index is not black, and also if the row is equal to 0, which means that it'd be in the first row, so by default it would have to be labeled because there's nothing above it, or the black squares at row -1 column. So that means that there's a black square above it. C is equal to 0, so it's the column is equal to 0, so it's in the first column. So the column that's all the way to the left. So by default, there's nothing to the right of it because it's in the first column. Or sorry, there's nothing to the left of it because it's in the first column. And also black squares at row index and column index -1. So that means that to the left of the square. So they just combined it into one statement. What I did is I did like multiple like if-else statements just because it's easier for me to understand. But if you wanted to, you could do it just in one statement. It'd be much more efficient. So are there any questions about part A and how you'd do the toBeLabeled method? So for part B, we have the crossword constructor. And the constructor should initialize a crossword puzzle grid to have the same dimensions as the parameter. And each element of the puzzle grid should be initialized with a reference to a square object, color, and number. The number is positive if the square is labeled, and 0 if the square is not labeled. So if we look at the answer key, basically to get the dimensions of the crossword to be the same as the dimensions of black squares, you create a variable for rows, which is basically just the length of the black squares array. So we're talking about row length since Java is row major. Create a variable called calls, which stores the length of the first array in black squares. And since it's a 2D array, then all the lengths of the same. So you can use the first length, use the second length, but to be clear, you should use the first length just because we're assuming that the black squares is at least has one row. And for puzzle, you just instantiate a new 2D array of squares using rows and columns. You didn't necessarily have to create rows and columns here. You could have just passed in black squares length and black squares at 0 dot length into the brackets for the 2D square array. But I don't know, just for readability, they chose to create variables for it. Create a num variable called 1, have a 2D array that goes through each row and each column, and it says if the square at the row and the column is to be labeled, you basically access that square in puzzle, and you create a new square. Initialize the first parameter to be false, and if I look back, for the square, the boolean is black. That's basically just saying if it's black or not. So you initialize it as false because in this case it would have to be white, and then initializing the num that you're passing in here, or that you declared here. And that makes sense because we're going in numerical order. So the first number that you initialize would be 1, the second would be 2, 3, 4. And then just increment the number here. If this if statement is false, then what you do is you would access the square at puzzle index with a new square, but it'd have the value of black squares at RC. And you have to do this is because black, but it also might be white, but it just might not be labeled. So you have to access that Boolean value to make sure that you know whether you want it to be black or white. And the number would just be 0, which I think they just said if the square is not labeled. Yeah, it said if the square is not labeled, just put it to 0. So yeah, that would be how you would implement that method. And I think that was it for this question. Yep, it goes right to question 4. So is there any questions about that? I know I kind of went over it fast, but I wanted to make sure that we got through everything. Any questions, Katie, Naraz? Okay, so all right, so thanks for coming to the webinar. I hope you learned something from this practice, and I hope that you guys have good luck studying for the AP exam. Now, if you have any other questions, and yeah, we'll probably have another webinar next week. So yeah. All right, no problem. All right, thanks for coming.